Good morning to all. This session is in continuation with the previous orthogonal set of signals. Let us start. Here we are going to discuss what do you mean by complete and closed set of orthogonal set of signals. After that, what is mean square error in the orthogonal set of signals. Let us start. Now, here we are going to discuss what do you mean by complete and closed set of signals. Complete and closed set of signals. Look at the word. In the previous case, the previous session we discussed orthogonal set of vectors. This complete and closed set of signals. Complete and closed set of signals. This concept is depending upon orthogonal set of signals. Orthogonal set of signals. Now just look at this point students have to remember. This concept is depending upon orthogonality principle. Individually there is no complete and closed set. So to discuss this one, we have to take orthogonality into consideration. What is orthogonal of the set? You know that. Let x1 of t, x2 of t, etc. xn of t all are, let it be, orthogonal set of signals. Let it be orthogonal set of signals. All are orthogonal set of signals. When this is set to be complete and closed, that means let us consider any other signal, not one from this one, any other signal, for example f of t. Consider any other signal other than this set of signals. If from the given time interval t1, t2, f of t into, you take any signal, any one of signal from the given set is not equal to 0, where m equal to 1, 2, etc. n. Look at, you have to take orthogonal set of signals. Now let us consider any signal other than, that means outside signal you take. Now you take the outside signal and you take even x1 or x2 or x3 up to xn, you take any signal and multiply them and integral over t1 to t2 dt. If it is not equal to 0, then it is called complete and closed set. If this is equal to 0, not complete and closed. Not complete and closed set. That means what? No other signal should exist to satisfy this condition. You take any other signal, no signal satisfy this condition, not equal to 0 output. If it is equal to 0, it is not complete and closed. So this is the important condition to become complete and closed set of signals. One important point is that complete and closed set of signal is depending upon only on orthogonal set of vectors, not general set of vectors. That is important point. Now next one. The next concept is called mean square error. Generally they are asking for 2 marks questions, simple questions. What do you mean by mean square error in orthogonal set of vectors? This is an orthogonal set of vectors. What is mean square error in orthogonal set of vectors? Again, just look at here. We are going to find mean square error. This concept also depends upon the concept of orthogonality. That means students have to find this. Have to notice this one. So after discussing orthogonality principle only, you will be able to discuss mean square error or complete and closed set of errors. So for these two topics, orthogonality is the heart. That's how you have to focus on orthogonality. Now, what is mean square error? For example, look at any signal can be written as x of t, some constant into x of t plus some x of the error. Now here one important point, mean square error. Mean square error means what? Just look at mean means what? Average. Squaring means what? Power 2. We are applying average and power on what? On error. On error function. Understanding? On error function. Now, from this, what you can make it? Error signal, you can write it as f of t minus c1 into x of t you can write for only one signal. If you consider more set of signals, then error of t is equal to, how you can write? F of t minus summation minus summation 1 to n c of k minus ck of t. It contains more signals. If you take only one signal, 1. If you take more signals, it will be like this. Now just look at what is mean square error. Mean square error means what? Squaring the error and applying average on it. That is called mean square error. Mean square error. Mean square is two important short answer. What do you mean by mean square error? Means finding square of the error. Upon that, applying the principle of average. Now just look at. For example, how to find direct formula I am writing you. What is mean square error? You take any signal over a time period t2 minus t1. Now, how to find mean square error? That is equal to, you take integral over the period t1, t2, that is equal to f of t minus of summation 1 to n ck square into x square of t of dt. This is the finding mean square error. Square, that means upon squaring, actually you can make it, you can go for another one. Do one thing. This is a direct step. Now, this is a mean square error. For example, look at how to find mean square error is equal to integral over the given period into what is the given one? Error. Now here, as per the definition, what we have to do? Square with respect to t. Just look at squaring the error. After squaring the error, what you have to find? Average. Average of what? The given time interval. Now just look at what is the given time interval? The given time interval is from t1 to t2. So how to find the average? Dividing by. Average means what? Width of the signal, t2 minus t1 whole square. Now just look at, this is the first part, squaring the error. Upon that, dividing by the width of the signal, T2 minus T1. This is average component. This is square component. This is average component. Now just look at, first squaring the error signal, upon that applying the average of that width of the signal. This is this one. Actually, proof is not required. You can directly just go for, its formula is T2 minus T1 between T1, T2 of f of t, f square of t minus summation 1 to n c square of k into xk of t. This is of dt. This is the direct formula of mean square error. Simplification, actually this square x of e, how to find x of e? This thing we have to make whole square, a minus b whole square. Here it will come like this only. Upon expansion, a square plus b square minus 2ab formula is there. Now after that, simplifying second and third terms, directly you got this substitution. Proof actually 100% not required. This is very short answer question. What do you mean by mean square error in orthogonal set of vectors? Now just look at, I am taking not ordinary set, orthogonal set of vectors, mean square error. Now just look at, so here this component comes under the square part. Here this is a simplification upon squaring the error. Here average of this entire signal. So this is called mean square error. So students have to remember that in mean square error, first step is to get the signal. Next one, find error. Next step, make error square. Third step, error square by average. Average means T2 minus T1. 3 steps are involving in mean square error problem. 3 important points, just look at how you can differentiate, how you can analyze the simple concept. First you have to find the error. Second step, find the error square of it. After that, divide the error square by average. That is the meaning of mean square error. So simply just take the error, after that square it, at last find average, that means mean. That is mean square error. Upon these 3, which one is important? Error is important. This is important. So this session contains, here we discussed 2 important points: closed and complete set of orthogonal set of signals. Second one, mean square error in orthogonal set of vectors. These 2 are very much important. Thank you.